So moving on from our knowledge of sequences, we're now going to move into a term called series. So a sequence is just a list of terms. So an infinite sequence could be term 1, term 2, term 3, all the way up to term infinity. A series is the sum of the terms in the sequence. So A1 or term 1 plus term 2 plus term 3 all the way up to term infinity. You can have an infinite series where you don't know where the sequence ends or the series ends, or you can have a partial sum, which is the sum of the first n terms in a sequence. This can also be called a finite series or an nth partial sum, but what it would be is you'd choose an end. So maybe you'd say, hey, I'm going to find the sum of the first 3 terms. So it would be the sum of first term, second term, and third term. So for our sequences or series right now, what we're going to look at is these nth partial sums. So if we've got the sum of 3 terms, you're going to take the sum of the first term, the second term, and the third term. So -2 plus 4 is 2, plus -6 is -4. All right, so then if you wanted to find the sum of the first 5 terms, or the 5th partial sum, pause the video and see what you would get. So hopefully you actually pause the video and you're coming back and you're telling me that -2 plus 4 plus -6 plus 8 plus -10 is -2 plus 4 is 2 plus -6 is -4, so +4, so -6. All right, moving on from there. The next thing is that mathematicians are way too lazy to say, find me the sum of the first 6 terms. So what they do is they come up with a notation that signifies sum. So this is called summation notation. The notation uses the Greek letter sigma, so that's this weird E here, and it shows you what you're going to find the sum of and for what formula. So this is saying that you're going to find the sum of the terms from where k is 1 to where k is 4 for the general term 2k minus 1. So that letter k tells you what number to start with putting in for k, and then the top one tells you what number to stop putting in for k, and you always use natural numbers, okay? So if I asked you to actually find the sum of 2k minus 1 from where k is 1 to k is 4, you'd put in k is 1, k is 2, k is 3, and k is 4, and then you would add the terms together. So for this one, this is asking you to find the sum for this general term or general formula from where k is 0 up to where k is 4. So pause the video and give this a go. All right, hopefully you're coming back and you've done -1 to the 0 times 5 to the 0 plus -1 to the 1 times 5 to the 1 all the way up to where n is 4. So -1 to the 4, 5 to the 4. So hopefully you've written all those out and then you add them together. So it should be 1 plus -5 plus 25 plus -125 and plus 625. And you should get 521. All right, so now you have to learn how to write sigma notation. So I'm going to give you a series. You're going to come up with the formula and you're going to write the sigma notation to find the sum of that series. So looking at this guy, hopefully you notice that it goes 1, 2, 4, 8, 16. Like this is kind of my signal here. You'll notice in this course there, you kind of get patterns where you're like, oh, they're always like a base of something with some sort of exponent. So 2 is 2 to the 1, 4 is 2 to the 2, 2 to the 3 is 8, 2 to the 4 is 16, and so on. So to get that 1, you have to start at 0. So my formula is going to be 2 to the n. And I kind of default back to n. It actually doesn't matter what letter. Like I know up here it has a k, right? If you use an n, that's totally fine. I'll use a k to be consistent, right? So I'm going to say 2 to the k. But I'm going to know that k has to start at 0. And then what is it going to go up to? So I'm going to start at k is 0. And then I want to look to what to put in for k for the last term. Well, there isn't a last term. This is an infinite series. So we're going to go up to where k is infinity. So to put that in sigma notation, you're going to draw this weird epsilon sign, and you're going to put in k is 0, because that's what we're going to start with, up to k is infinity for the general formula 2 to the k. All right, pause the video. See if you can give this one a go. So hopefully you're coming back. So the first thing I hope you notice is that this is an alternating sequence. So we're going to start with having a -1 to the something. And then this is 2, 4, 6, 8, 10. These are all your even numbers. So to get it, you're just going to do 2 times whatever you put in for n. So I'm going to put in, sorry, k. I'm going to put 2k. So when k is 1, I get 2. When k is 2, I get 4. When k is 3, I get 6. When k is 4, I get 8. When k is 5, I get 10. Does that work with -1? Well, I want my first term to be negative, so I want my first one to be an odd number. So if I put in 1, it gets negative. Put in 2, positive, 3, negative, and so on. So this works. This is my formula. And I'm starting where k is 1 up till, so k is 1, 2, 3, 4, 5. So your sigma notation, you would draw your summation notation. You'd start from where k is 1. You'd go up to k is 5. For the equation, -1 to the k to k. All right, so now you should be doing a quick check to make sure that you understand this. Do as many questions as you need to do to understand the material.